everyone, welcome to another Unity 5 tutorial. Today I'm going to show you how to build a melee system using the skeleton that we had in an AI tutorial a little while ago. So this is the end of the line of sight tutorial. So if you want to follow on, you'll need to go through those steps there. So if we run it, what you've got is a first person controller for your player that can move around. And as you get up near this guy and he notices you're there, he starts to walk towards you and attack you. So what we're going to add to this is a system whereby we can attack him, and we'll have some health bars on the screen that show the health of him and also of us, our character. All right, so let's start. First of all, what I'd like to do is to remove the first person controller and to build our own. So this is the Unity first person controller, and it's got all of this stuff on it. Now, to implement what we're going to do is going to be a bit mucky to dig around in this code, so it's best if we just start with some really basic character controller code. All right, so to get started, we're going to delete the first person controller. Not rename it, delete it. Okay. Now, once you've done that, because there was a camera attached to it, you're not going to have a camera in here, but that's all right. Don't panic. So we'll make our character the same as the skeleton. So we'll just grab this skeleton from here and Control D to duplicate it. And that will give us a second skeleton in here. We can drag out. This will become our character. And in order for our character to see, it needs a camera. So let's rename this skeleton as our player so we can find it easier. And right click on it and add a camera. And so now the camera is attached to the player as well as its skeleton. And if you have a look over here in the scene, if we just move around, you can see the camera that it's facing forward, and you can also see what the camera's seeing here as well. Now, the camera, you'll want it to be at, say, the head position of your character. Let's just zoom in a little closer on this guy. And if we look at this camera again, the near plane of the camera is actually behind his eyes, which is giving us this kind of shadow from being inside of the head mesh. Where you put this camera is up to you. Now, I will admit that this is not the best model to have as a first-person character model, but it's here, it's got the animations, and we're going to use it. But you can add your own model. Now, if you want to move that camera forward, if we just select the camera, we can move it and stick it in front of his face like that. The only issue is that when he is animated, when we press play, if we just have a look at his animation, he'll be in idle, because he's going to have exactly the same movements on him as the other skeleton. And as his head goes through this far plane here, it's going to cut across in front of our camera. Now, we kind of want the camera to be able to see our player, so if we look downwards, we'll be able to see our feet and our arms when they slash out as well. If you wanted to make this into a third person kind of arrangement, all you got to do is just move the camera back like that, and then the camera will follow your player around because it's attached. But we're going to sort of fake this first person kind of thing, and we'll stick it in front. Okay, so we'll just live with this head thing at the moment. If you had a better model where the head was a separate object from the body, as you can see in this mesh, it's all one piece, so you can't actually make the head invisible by itself without turning the entire body off. But if you had such a model, you could do that. But we won't worry about that. So we can just grab our camera. If it's really annoying you, you can just move it forward a bit so it's sort of out of his way. You could even kind of move it up if you wanted. Anyway, the point of this is to show you how this system works, not to fix this particular animation. Okay, now we've copied our player from the skeleton. We also deleted our FPS player, which at the same time meant that the chase script that's attached to your skeleton for the AI to work is missing our player. And so we have to grab our player again and drag it across onto here so that the AI now knows where our player is. And you can see that I was in play mode, so he's starting to attack us immediately. Let's just stop that and check that that still worked. Okay, so drag the player into there. Now, the player character has this chase script and we don't need it. So let's just remove that. Okay. Now, the script for the player itself is going to be accessing the skeleton animation controls, which we've got over here. And we've got the same set of animations. So the skeleton will be idle, walk, attack, etc. But our script that we attach can still access this animation controller, but at different times depending on what we're doing. So we can actually leave that same animation controller there. If you were to have a different character, then you would need to have a different set of animations. All right, so what do we need to do next is to put some kind of controller on our character so that we can move it around. And it's got no script on it at the moment. So let's create a new script and we'll call it character controller. So create C# script, character controller. And then open that up. And we'll edit this code. Right, so instead of typing all this, I'm just going to paste in the code that we're going to need. And let's go up to the top here and I'll go through it all. So this code was taken from the Mech Anim Basics tutorial that I wrote with Granny that walks around and jumps. So it's using the same base drive code that comes with the Unity scripting reference on the Get Access page, as I've explained before. So this will look familiar to you. We've got this animator at the top to begin with, and the animator is so that we can grab hold of the animations and control them that are on our player character. Okay, so this is all about our player character. This has nothing to do with our enemy at the moment. The speed and rotation is going to work based on the movements of your character. Now, if we look through this code, you'll actually see I've taken away the rotations. So I'm not actually using that anymore, so I'm just going to remove it so you don't have to type it out. Okay, in the start function, we grab hold of the animator that's attached to our character so that we can control the animations. And then we use this here, this cursor dot lock state, and set it to cursor lock mode dot locked. And what that does is to make your cursor disappear and lock it into the screen so that when you start moving the cursor around to control the movement of your character, you can't see the little arrow on the screen and it won't go outside of the game screen area. Now, in order to get out of the game, you actually do need to get your cursor back so that you can go and press stop play or pause or whatever in the editor. So to cater for that, you'll see some code at the bottom of the update function in a moment. Right, so the update function looks like this. We start with our translation as we've done many, many times before. But with the rotation, I've changed it to a strafe. So instead of turning around, you actually move from side to side. And we're going to use the horizontal axis for this, which is going to be our left and right arrow keys. We then multiply our translation by the delta time. So this is the time that has gone by since the last update, and it keeps your movements nice and smooth and uniform as well based on the time. Strafe is exactly the same. Now, translation and strafe are actually translations. So translation is a movement, is going to be the movement forward on the z-axis, and the strafe will be the movement on the x-axis from side to side. So we can do all of that in the one statement where we translate our character using our strafe value and our translation value. Notice that the y is always 0, so our character is not going to move up and down, just left and right and forward and back. All right, so to now control all of our animations that are in that skeleton animator controller, I've got the fire button, which will be a click on the left mouse button if you're using the mouse by default. So when this mouse button is being held down, it's going to keep setting this attacking to true. And so it will have your player character swinging the sword. If it's not happening, then it stops the attacking so that you won't attack. Now further down, we then have if our translation is not 0. So if we're actually moving forward or backwards, then we're going to set is walking to true. And we're going to set the idle to false. So idle in the animation controller is our default animator. If you're not familiar with the Mech Anim system, and this is getting a little confusing for you, I do recommend very highly that you go back and have a look at my Mech Anim basics tutorial, and that you also follow through with the line of sight AI character that sets up this skeleton. Otherwise, you're going to get a little lost with this code. Now, if we're not moving forward, we're going to set walking to false and idle back to true. You'll notice I haven't put the strafe in here for sideways walking. You could put if translation is not equal 0 and strafe is not equal to 0, or strafe is not equal to 0, then you could be walking sideways as well. If you wanted to make this quite polished, you'd have a sort of sideways walking movement in your animations, which you could then program into this part. For now, we're not really going to worry about that because we're more focused on the attacking and recording hits system in this tutorial. Right, now at the very bottom of our update function, we have a get key down escape. So when you hit the escape key, it's going to turn off that lock state that we put up here in the start, which means you'll get your cursor back and you'll be able to move outside of the game window in order to stop the game playing when you're in the editor, or go to other windows. Right, so let's just save that. And we'll just switch back to Unity. We're going to attach that script to our player. Okay, and you can adjust the speed here at which they move forward as well. So let's just play at this point. Now I'll be able to use the arrow keys to move my character forward and back. Let's not worry about the guy that's trying to attack us. And you'll notice in this scene that the walk animation does start to play when we're moving forwards and backwards. And he's probably moving a little bit too fast for the actual animations himself. So that's where you could come and, this is where I need to hit escape to get my mouse back, set this speed to a lot slower so that it fits in with those movements. So let's sort of halve it to 5 and run. Okay, so when I move forward, he still looks like he's skating across that surface, so his movement forward probably needs to be even slower than that. 2. Again, this is not the point of this tutorial. That's a bit better. So he's at 2. See how he's a lot slower. He's still slipping a really small amount, but that's all right. We'll leave it like that. Okay, now, if you move the arrow keys to the side, you'll see that he moves to the side and moves back the other way, but there's no animation for that. Okay, now, what's our problem that we've got? We can't turn around. We're stuck looking in one direction. So to fix that and to align with many other types of first-person games like this, we will program for the camera itself to do all the looking around and then make the character move in the direction that he is actually looking. So to do that, we need another script, and let's call this, let's create a C# script. Let's call it cam mouse look. Now, there is a mouse look script that comes with the first person controller, but you can't use it because it actually relies on a lot of the other things that are attached to the Unity default FPS controller. So we're going to write our own, which will be nice and simple. So open up this script, and I'm going to cut and paste the code that you need in here. Okay, so this code here, let's paste it, is nice and short once again. And what it's going to do is to move the camera around based on the movements of the mouse, so that when we move horizontally, you want the camera to look horizontal, and when we move up and down, you want it to move vertically as well. The other thing that you want is that depending on which direction you're actually looking, that's the way that your character is going to turn as well. So this code needs access to our character, which we will do through this game object here, character. And it's set up in the start function. So character equals the parent object of the thing that this code is attached to. And this code will be attached to our camera, which is attached to the character. Okay, then in the update function, what we're doing is we're getting the change in the mouse movement. So this is like the mouse's delta, MD, which will get axis for mouse X and mouse Y movements. And what we do then is we scale that value down based on a sensitivity and a smoothing value for the X and the Y values of our mouse. Now, sensitivity and smoothing is set up here. So if you want to modify those, you can change these values. They're also public, so you'll see them exposed in the inspector where you can change them and fiddle around until you get them right. Okay, next, we're going to smooth the movement of the mouse look using a lerp. Now, if you don't do this step here, then you'll get kind of jerky movements as you're moving the mouse around because the update function doesn't run at regular intervals. So if your computer goes off and does something else in the background, you might find there's a little jerk in the movement. But with smoothing and lerping between the movements, then you're going to get a lot smoother movement out of your mouse look. Okay, we then use our smooth value and we add it to this variable called mouse look. So mouse look, which is defined at the top, is a two-dimensional vector. So it's got an X and a Y, and it keeps track of the total movement of the mouse so that it can add that to the transformation of your character, as well as the angle in which the camera is looking. Now, the point that we do that is down here. So we use a local local rotation on the transform of the camera, and we set that to the Y of the mouse look, or I should say the negative Y of the mouse look, which is going to rotate the camera around its right axis. Now, you know how you can have an inverted system in your looking in first-person shooter games? Then this is where it is. This is why it's minus. So this is basically your inverted system. You could make that a positive value if you want it to work in the other direction. So rotating around the right axis, if I go back to Unity just for a second for you, find my camera. So this is the camera. Trying to get a good view. If we hit the E key so that we can see the rotations of it. Okay, so when the camera is looking straight ahead like that, when it moves up and down, it actually rotates around its x-axis. And the x-axis, which is shown in red, if I go to press W, this is our right axis for our camera. So if we rotate around that axis, we're going to be looking up and down. So I go back to E, and if I use this here, you can see that if I rotate around the right axis, it's doing that, which is exactly what we want to do when the mouse is moving up and down in our game window. Now, if we are going to look this way and this way, then hit the W again. When we rotate this way and this way, we're actually rotating around the y-axis because the y-axis is the one going up. So that's the green one. So where we rotate to look like that, which is what our code is doing. So if I go back to that code here, so we're rotating around the right axis of the camera when we're looking up and down. And then when we're looking left and right, we're going to change the character's transform. So this is where we actually turn the character around using the camera's direction. And we use our mouse look X value, which is these ones going this way, to rotate around the up axis of the character, not the up axis of the camera. Okay, so that's all of the code. It's nice and short. So let's save it. Go back to Unity and grab that mouse look code and attach it to your camera object. Okay, and the camera object is attached to player. Yes, that was Merlin snoring. He's probably about to start snoring more, so excuse him as he has a little snooze under the desk. Let's play it and have a look what our camera is doing now. So here's our camera. It's actually quite sensitive. You could turn that down if you want. And I will now, if you have a look in the scene view, you can see that my character is moving around with the camera, but when I look up and down, he doesn't rotate, which is not what you want. So now if I use the arrow keys, he will wander off in the direction that we want. Now, because we have him as our first person player, he'll be able to see your feet and arms as you're moving as well. At this point, you might think that you probably need to put the camera a little bit in front of your character because you don't really want to be able to see his entire body when you're looking down. Okay, this guy is still attacking us. Okay, so it's time to attack him back, I think. Okay, press escape to get a mouse back so I can stop playing. Now, if we're going to hit this guy, then he needs to have a collider on him so we can register those hits. Now, this is the AI character, not our character. So this is the skeleton. And to him, we're going to add a capsule collider. So go to the inspector and go add component, and we want a collider. And it doesn't really matter what collider you add at this point. It will only matter it'll only matter as far as him actually being hit. Now, you could add a mesh collider if you want to be extremely accurate about him being hit, but your performance will go down a fair bit. I'm going to add a capsule collider because I think that's probably enough. Now, this guy is actually quite small, and if we go out, you can see we've got a huge collider around him. So we need to bring that collider down just over in the inspector by modifying its values here. The height is just way off. Let's bring that down and we will lift it up. The AI character himself is not being moved at all by the physics system, so this capsule isn't going to cause him to fall through the floor or not be able to move or anything. It's just going to register hits. The bigger you make it, the easier it will be to hit him. And I might regret a little later when I start playing that I've made this so accurately small. Small values make it quite difficult to move around, so let's just try 7 here. That might do. Okay, so he's got a capsule collider on him now that's going to register hits. We're also going to make that capsule collider a trigger, and we'll use an on trigger to detect that being hit. Right, now the next question is, what is going to hit him? So obviously in this particular scenario, it's going to be the sword of our player. Now, to register this hit, I could put all matter of colliders around this sword to do the hit. But all I'm going to do in this instance is just add a little sphere on the tip, and we'll use that as our collider. So go to your player, and what you want to do is find the transformation of his weapon, which is the sword. Now, it is in this list. Turn that back on. Yours shouldn't be turned off. I don't know why that's off. Okay, we're not touching this. At the bottom, there is this BIP001 prop 1. That's the transform of the sword. And if you move that in the scene, you actually see that is moving his sword around. Okay, and the transform of the sword is operating from right back at the handle of the sword. Okay, so anything we now attach to this sword will move with the transform as that sword moves. So what I'm going to do is, with the sword selected in the hierarchy, I'm going to right click on it and add a sphere. Now that sphere is absolutely massive. If we zoom out, you can see it there. So let's just shrink that right down and make it very tiny. And then I'm going to move it. Now, because it's already attached to the sword, it's going to move in relation to the sword. So it doesn't matter where you put it. When that sword, if I go back up here and actually manually rotate it around for you, you'll see that it's going to move with it anyway. Now, the size of this will depend on how accurate you want to be with hitting the other skeleton. And you know what? I might make this a little bit bigger, because I don't know why I'm making this so difficult for me. Okay, so when this sphere hits the other guy's collider, then we're going to register a hit. Now, of course, you don't want this sphere to appear in your game, so you can turn off the mesh renderer for it so that it's actually still there and will register a hit. Now, the sphere collider that comes with the default sphere is fine to use. Let's just make it also a trigger. Right, so now it's time to do a little bit of coding to register some hits. Right, so let's create some code, and we'll call this script detect hit. And this script will be attached to the skeleton, our enemy, and it's going to use an onTrigger enter function. Now, I always find when I'm programming with onTriggers and onColliders that it's really best practice to put the function in, and then inside that function just put a debug line to test that this is actually working the way you want it to work. Before you go ahead and put all this elaborate code in there, assuming that it's going to work, okay? Because colliders and triggers require certain conditions for them to actually run, and remembering what they are, there's a big table in the Unity reference script that you can have a look at, but I always forget what it is. So I just do this because it's easy for me to see that I'm remembering it right, as well as also debugging, I guess, that we're on the right track. So let's put that in there to begin with. And we'll attach that code detect hit to our skeleton. So it needs to be attached to the same object that has the collider. Okay, you can't attach it to a sub-object. It will not work. The collider and the script relating to that collider need to be in the same space. Okay, so now if I play this, and I need to turn that mouse sensitivity down. Okay, this guy's chasing us. Let's turn around. Now, if I hold down the mouse button, the first thing that we can see there is that he's not attacking very well. You can see my character is bouncing back and forth. So he's going into an attack, but he's not actually going through with the attack before he goes back into an idle. So the first thing we need to fix for that to work is our skeleton animation controller that we've got on both of our characters. The reason that is happening is he's going from a walk to attack or an idle to an attack, and the attack is not finishing before it goes back to the other states. That occurs on the transition, and I have talked about this before, is that by having this has exit time turned off, the animations are allowed to be interrupted. So what's happening with that character is that his attack animation is being interrupted in the script. He's not being allowed to finish attacking. So we actually need to have it turned on going from the attack to any other transition, so that he finishes attacking before he goes into another state. Okay, so let's just go back now that we've turned those on and try again. So as our character, when we attack, let's attack just nothing. Hold down the mouse button and you can see that he's now finishing his attack animation. Okay, so that's good. So let's look around and find this guy that we're meant to be attacking and try and attack him. What we're looking for at this point is to see whether our sphere on the end is registering any hits. And those hits are going to appear down in the console down here. So you will get hit written down here when those triggers hit each other, which they're not doing. The reason why is because this sphere has a collider and the skeleton guy has a collider. But in order for a trigger or a collision to be detected, one of those objects needs to have a rigid body, and neither of them do. We're going to put a rigid body on the sphere. So let's go into add component and go rigid body. And let's spell it correctly. So we're adding our rigid body. Now, this rigid body, we don't want it to be in the physics system. We do not want that sphere to fall off of the sword and do its own thing. So I'm going to turn gravity off and I'm going to click is kinematic, which will allow our sphere to be a rigid body. It will then register hits with other colliders, but it won't actually react to any physics system stuff that's going on. Right, so that should fix that problem. Let's play again and let's go and try and attack this guy. Okay, great. Now, did you see what happened when I did hit him? Get my mouse back. Down here in the console, you can see that that debug line is working now. So we are actually hitting him down here, which is great. Okay, so now that we know that we're hitting that skeleton, we can start to work on decreasing his health value. So to keep track of his health, we'll use a slider. And this is the same health bar system that I created in the health bar tutorial. So to do that, we right click in the hierarchy and we go down to the UE system and select slider. That will create this slider here for us automatically. And if we go into the 2D view by clicking 2D in the scene and zoom out to see the actual screen, you can see that our slider's down this bottom corner. Now to move it up to here where I want it, we're going to go into the inspector and find this little rectangle thing here. Select it. You want to anchor it up to that top corner, and you also want to Alt click and move it to that top corner as well. And you can see the anchor for it, which is this little daisy type looking target thing, is now up in that top corner. What that means is when we move our game and change that game view resolution, that this will always stay clamped up in this top corner. Now if you don't want it perfectly up in that top corner, that's fine. We can just grab the slider itself and move it. Click on here to get the points and drag it down to there. Okay, and you can see that it moves it. It's still relatively anchored to that point. Right, now this is a slider that you get to set values like you would see in a options system. We're going to use it as a health bar. So first of all, we don't want that handle, which is that little knobby bit there. So we can just select the handle and delete it. And what we're left with is the slider itself, and it's got a background and a fill area. The background is what's underneath. You can probably just see that little knob there. That shows you the value the slider is set to, and the background is what's behind there. So in a health bar, when our health is low, it usually says it's red. So let's change that background to red by setting the image color to red over in the inspector for the background. And for the fill area, if we just go down into here, you'll find where the fill graphics is, and we can set that to green. and you'll see it's green there. Now, the slider itself is where the values are stored. And if you select the slider and have a look in the inspector, let's go down a little bit to where you'll find the min value and the max value. So the max value is set to 1. We're going to have health of 100 as our highest health value. We're going to use whole numbers. And the current value of the slider, which you can see here, is set to 0. We're going to have it set to 100, so it's 100% health to start with. When you set it at that value, you'll be able to see that there's also this little bit of red that pokes out at the end. So you can actually grab hold of the background and just drag it in so that it's the same size as the green part, so that when you've got 100% health, you can't see any red. Right, okay, so now we might just change the height of the slider. Just select the slider, and in the inspector you can just modify its value there just to make it a little bit prettier. And you can also change its width if you want to do that as well. Okay, so this is our slider that's going to show us how healthy the attacking AI is. You could also add some text in there that says, skeleton health if you wanted to, which is just a matter of putting another UI element in there. Right, so to control this slider, we now need to modify our hit code that's on our skeleton. So back in the detect hit code, we're going to grab hold of the slider, which we will make a public exposed variable to set in the inspector. And let's call this health bar. Now, to use that slider, we need access to the Unity library that has the UI elements in it. So we go Unity engine.ui up here. We have hold of our health bar, and then when we get hit, we're going to decrease the value on that health bar. So let's go health bar dot value, because it was the value part of that health bar, minus equals, and let's make it easy for us. So let's put 20. Now this hit, we don't need anymore, this debug line, so we can actually get rid of that. And that's pretty much all we need in here for now. So save that, go back to Unity, and select your skeleton and find the now exposed health bar value that's in the inspector, which is down here. We want to grab our slider and drag and drop it into that position so that our script has access to our slider. And that when we get hit, it should decrease. Sorry, when the other character gets hit, it will decrease its health by 20. And we should see it appear on this slider. So let's play it. And where's that character? Here he is. So I'm going to start attacking him. Get a bit closer. I'm actually quite rubbish at this, but oh, there we go, I've hit him. Okay, so it takes a few hits to get him. And you can see that that health bar is now declining. Right. What happens when it gets to 0? Well, nothing. He's still alive. His value for health is now 0 or less. But he's still fighting us because he hasn't actually been told that he's dead. So we need to set up a death animation that will make him fall over and die. So let's just stop this. And first of all, we need to set that death animation up in our skeleton animation controller. So if we go back to our skeleton animation controller here, our animator, and if you go back into the animations that came with the skeleton, you'll find there's a death animation in that list of animations. Now, I'm going to drag and drop that, put it up here. So this is our death animation, and we need to make a transition that will call our death animation. So let's add in the parameters list a bool value, and we will call it isDead. Okay, and we're going to use that state to die. Now, you can die from any state from being idle, walking, or attacking. So let's go make transition from any state to our death animation. So this any state represents putting our death animation like down here and actually linking to it from all of these. This will take care of it. On the transition, we're going to set our list of conditions to is dead, is true here. Now we're going to make sure that there is no exit time so that it doesn't continue playing through the animations before he dies. So he'll die immediately, essentially. Okay, so we've got that in the animation. We now need to control it with the code. So back in our detect hit script, we need to access the animation. So I need a variable at the top, animator, anim. And then in the start function, we'll grab hold of the animation controller that's on the skeleton with anim equals get component animator. Like that. And then in this on trigger, we can then test for the health bar value. If health bar dot value is less than or equal to 0, then we're going to play the death animation. Anim dot set bool is dead to true. Okay, now because I'm such a lousy shot, to test this, I'm just going to make this health value 30, so it's pretty much 4 hits and he's down. Let's save that and go back into Unity. Put the scene up so that we can see the action in that view as well. So this is our skeleton guy, and we are just there. All right, so let's run this. Where is he? Okay, so now I need to attack him. And when his health gets right down to 0, seriously, I'm such a lousy attacker. Here we go. I'm starting to hit him. Oh, I should have had a one-hit kill on this. Try and move back a bit. Okay, now I'm actually hitting him. He was too close before for the collider to hit his collider. Okay, come on, I can do it. Right, there we go. Okay, he's dead, but look what's happening. His death animation is trying to play. So what's happening here is that if we can switch back to the animator, you can see here what's happening is this is constantly triggering because he's dead. So it's going from any state, even though he's in death, he's going from death to death to death to death to death, and it keeps playing the start of that death animation over and over again. So what we can actually do on this transition here is that there's a setting in the inspector for it. If we go down to the settings, that if I just move this out, there's a can transition to self. And if we untick that, that will stop the death animation being able to trigger to itself because we're using of this any state. Okay, so now if I play this, and what I'm going to do is actually make it much easier to hit him because it's painful watching me play. Go back to this guy and make his collider bigger. So let's increase the radius of that. Okay, that's quite big. Right, so let's play and let's start attacking. Yeah, much easier to hit him. And when he dies after the next one, his death animation plays. Okay, now what happens is he's going to be in that dead state as far as the animation's concerned. But if I start moving away, look what's happening. His AI script is still working because he still is going to start walking after us because we're within a certain distance of him. And that's what he was built to do. So besides telling the animation that he's dead, we also need to tell his AI script that he's actually dead so that he won't follow us around lying on the ground like that, which is a bit strange. Now, since he's using the value of this actual slider as his health value, we can test for what it is inside the AI script as well. So if you click on the skeleton and open up the chase code, which is his AI, we want to grab hold of that slider. So public slider health bar. And at the top, remember, you need to put in the using Unity engine.ui like that. Okay, we've got the health bar. Then down in update, before any of this updating happens, okay, this is the AI stuff. We can put at the very top if what's it called? Health bar dot value is less than or equal to 0, then he's dead, and we can just run a return here straight away, which will stop the rest of the code running so that he won't keep following us around. So saving that, switching back to Unity and doing another test. But before we do, we need to make sure that that chase script knows about the slider, which it doesn't at this point here. So let's just grab that down there. Otherwise, it's not going to have a value that it can test against. So let's run it. And he's going to start attacking immediately. Let's get on this. Attack him. And 2 more times, and he should be down. Here we go. Right, he's dead. Fantastic. Now, if we move slowly away from him, his AI script has stopped working. So we've got one character working. Now we need to get the other character working. So our player needs to get damage as well. Right, so we need to go through the same set of steps that we went through with the skeleton. So first of all, we need to add a capsule collider onto him so that the other skeleton has something to hit against. And we'll make our radius small. Move that up a bit. Okay, that's not too bad. I'm not really worried about the accuracy. If you want to see this fight go down, they might need quite large colliders to aim for. Now we go back to our skeleton guy, and he needs to have the little ball added to the end of his sword, which is this prop one. So we add a 3D object sphere, which again will be huge, and we just need to scale that right down. Move it to the end of his sword and add the rigid body. Okay, the rigid body is kinematic. The sphere collider need to be a trigger, which means that the collider on our player that we've just added also needs to be a trigger. So we want to select that as well. Okay, so we've got the hit detection code that we used on the skeleton. So I can drag and drop that onto the player. It requires a health bar. So we need to create another health bar for the player. So in the canvas, I'll just rename this slider to slider AI, so we know that's the AI slider. And then in the canvas, I'm going to right click UI and add another slider, which is there, and we want it to stick it up in this top corner. So we'll go into our rect transform and go over to here to select its pivot point. Sorry, it's anchor, not its pivot point, and to alt click as well to push it up to here. Then we remove the handle, and then we set the color for the background. which is in the background's image. And then we go into the fill area and go down to fill and set the fill color to green. Go back to the slider, which I'm going to call slider player, so I know it's the right one. Set its value, maximum value, to 100, whole numbers, and set it to 100. Okay, and we also need to change the size of it. So the background area, let's go back to the 2D view. You can do this in the inspector. I find it sort of easier to align things in here. If we click on the background area, we can just move that in like that, and then select the slider as a whole and change its height and width to whatever you want. And you can also then move it around until it's right. Okay, so it's not perfect, but it'll do for now for demonstration purposes. Right, so the player can now learn about their slider here. So let's take our player slider and drag and drop it into the detect hit script that is on our player. Okay, let's run and see how we go with this. Okay, so you can see that our health is going down. The skeleton's health went down. Mine is slowly going down. I'm not fighting. His health went down without me even trying to do anything, and now I'm dead as well. What has happened is that the colliders that we've got on the end of the swords are also colliding with our own colliders. So we're actually essentially killing ourselves by having those colliders in there. And what you need to do, therefore, is distinguish when you're getting hit as to who you got hit by, to stop the system killing you when you basically hit yourself. Okay, so let's add a little bit more into our code to fix that. Now, to test whose sphere, whose sword hit whose body collider, we're going to have to put tags on these particular spheres. Now, if you do this system as well and you've got friendlies in the game that you can't hit, this will also work for you. So our skeleton, our AI skeleton sphere, I'm going to tag that with a tag I made earlier and call it enemy. And take notice of how you spell these as well. So it's enemy with a little e. And then the sphere that's on our player, we're going to call that our player's sphere tag. So that we're only going to register hits when an enemy hits the player's collider and when the player hits the enemy's collider, which will stop their spheres from hitting themselves. Okay, so with those tags set, we can now test for the tags in the detect hit code. Remember, the detect hit code is attached to both players, so whatever we do to it is going to affect both of those characters. Open up the detect hit code, and we're going to create a public at the top string. Is it a small s? String, yes. Public string. And let's call it our, what do I want to call it? Enemy. Opponent. Then whatever the opponent is set to, we can then test if the collider that has hit us has the same name as our opponent, then it's allowed to do damage to us. So in this on trigger, I'm just going to put if other, which is the thing that's hit our collider, other.gameObject.tag does not equal the opponent, then we can return out of this function without doing anything. So it's very important what you type into this exposed variable as to whether this is going to register a hit or not. So we save that and go back to Unity. Now in the skeleton, select the skeleton, the AI character, and go down to opponent. You can see it here. So the opponent of this skeleton is player. So type in player, the tag, exactly the same as you've got here. And then you want to go down to the player here and type the opponent in as enemy, like that. So that these values will come through, and we're going to detect hit here. The tag is going to be tested against what's been typed in for each of these, which allows you to use exactly the same code on both of those characters, but have this as a variable. Right, so with that saved, if I come back here and just check again, that's got that's got player, because that's the enemy AI. Player has enemy written in it. Let's now play. Now I'm going to start by running away. I should say walking away. He's not going very fast, so that we're not getting hit. Okay, now as he comes up and starts to hit me, and I'll try and hit him as well, he has now been hit. Okay, he obviously hit me with his sword when he fell over, but the system is now working. Okay, so that is a melee system, a very simple one. It shows you how to create the colliders and to set them up, and the health bars as well, so that each character is fighting against the other and doing damage. Obviously, to make it easier, you could make your collider bigger, either the player's collider or the actual weapon that you're using's collider as well. So if the entire sword was turned into a box collider around that, obviously it would do a lot more damage when it's being hit. So in that way, you could make different weapons do different types of damage, be harder to use, not by programming it, but just by changing the size of those colliders. All right, so that's the end of that tutorial. Thank you for everyone who requested the Melee tutorial. If you're after a tutorial or you want to vote for other tutorials, which one will be next, it's on the website. So if you go to holistic3d.com/tutorials, you'll see an area where you can vote for ones that are already in the list. And you can also send me an email from that same link and request your own tutorial. So until next time, happy unitying.